All right. I'm going to try to do a clump of study goals together here. And I have to hope that by now you know that soil is a blend of inorganic material like sand, clay, silt, and organic material like little pieces of animal and little pieces of plant that are decomposing. This is the non-living, the inorganic, and the organic is the stuff of life. We would say it's little bits of biosphere mixed into the um, lithosphere. Now, I gotta help you consider something which is actually a really cool way to think about the planet. I have this conversation with grown-ups all the time. I was just talking to a colleague a couple days ago about this. In nature, you've got all these things which are adding biomass and very little that's removing biomass. You've got inputs but no outputs. Like take any given ecosystem. Sunlight is providing energy. There are gases cycling in the air and there are dissolved nutrients coming in the water. And when you add energy, producers will take these basic nutrients and build them up into the molecules of life. Proteins, fats, sugars, and so on. Molecules of life. Then some animal's going to eat the plant and chew it up and spit some things out and crap some things out. And then that animal gets eaten by another animal and that one spits things out and craps things out and all these things die. And basically they're all going to come back to the earth somehow to be decomposed and added to more biomass. Because you're giving it more energy and there's more gases and dissolved nutrients, you get this super fascinating pattern that in nature over time, organic material is being made, it's cycling around, and it doesn't leave or anything. It just usually accumulates. Maybe you get a flood that takes away some stuff. Sure, maybe you get a fire that puts some in the atmosphere. But unless you avoid these unusual events, right? Uh, unless you have these unusual events in nature, biomass is being added all the time. Producers make more stuff and it just cycles. You know, it's like a growing economy. Like nobody's taking out the money and more people make more money. And so you just have more money in the economy. It grows, the volume gets bigger. Now, agriculture is fundamentally different in two ways. First of all, there's less productivity because you get rid of all the stuff that used to live there and now it's just broccoli. Part of the time, broccoli, just broccoli. Like all the stuff that used to be there, all the interesting bugs and all the different types of producers and all the diversity of life and all the other seasons is now just like broccoli. And then for a big part of the year, you got no broccoli. For a big part of the year, all the broccoli's tiny. So with less diversity and less producers, you've got less input of biomass. They're not making biomass. And then what we do is when all the broccoli is at the sweet spot, we cut it all down and we drive it out of there. So there's less input, and unlike nature, agriculture is using that same concept, but then we extract it. Right? Like that's what farming is. This isn't rocket science. So now think about the idea that in agriculture, organic material is made less, rarely cycles, and always leaves, right? Because you take it off the farm. So where nature builds and accumulates more and more soil, agriculture tends to use up soil. Remember, that's called desertification, when the quality of soil goes away. Separate from the erosion, of the soil leaving. Desertification is the quality. It is less able to support life. Like a desert. So with less inputs and more outputs, soil gets used up. And this is kind of at the heart of a big divide. This study goal didn't have a star, but it's critical to understand other things. So I'm going to do this anyway. I'd like you to think about two different ways to manage soil. This is study goal number 10. In conventional modern chemical agriculture, you know that the soil is being used up. That's not a secret. Any farmer knows this. This isn't an opinion. It's just basic, right? Less inputs, more output. So if you know that the soil is running out at all times, you got to figure out how to keep these plants growing. So something has to be added. And the fastest, cheapest, most easily managed way that we figured out to do this was chemistry, synthetic fertilizers. This is called demand-based agriculture because what you're focusing on is that your plants demand more stuff. They need things. You know that the nutrients are going to run out and something is going to limit the growth of plants. That's called a limiting factor. So we got to figure out what's missing, and then we got to make sure we add it. As a matter of fact, there's this guy who said something is going to run out. At any given time, a plant would keep growing if it didn't need something. This is what's called demand-based agriculture. We know that plants would keep growing, but if it's not growing, it must need something. Liebig's law. There's always a limiting factor. Now, that's an interesting way to think about farming. The traditional hippie way to think about farming, which is kind of the old school way before chemistry. When I say primitive, I don't mean that as a pejorative. I just mean like older agriculture. The idea here is that you should just focus on soil. Like, make your farm work like nature, right? So make sure that there's a whole lot of inputs to the soil. And then as long as stuff is decomposing, whatever your plants need is probably coming on deck right about now, because something's going to be decomposing. So hippies like me, the sustainable, organic, progressive, I don't know how to say this, like the hippie way to do farming is to just farm dirt. This is true of all the hippie farmers you'll ever meet. Ask them. It's fascinating how much they think about dirt. Hippies say, I'm just going to farm the soil. Plants are going to happen. I just focus on soil. And this is what we call the other extreme, resource-based agriculture, where you just keep adding stuff. The focus here is to just keep that soil ecosystem happy, right? As long as you've got a diversity of producers and decomposers, and as long as you keep adding organic material, that's why hippies talk about compost and hippies talk about mulch, hippies talk about cover crop, hippies talk about native stuff. What we like to do is to just make sure you're building more soil. Because at any given time, you could figure out what a plant needs, or you could just make sure that everything possible is already there. Like, demand-based agriculture is to have a family in a house with an empty pantry. And then you take a blood test and it's like, oh, my daughter needs vitamin C's. And so you like run over to the store and you buy an orange and you juice the orange and you go, here, kid, have vitamin C. And then you take a next blood test and it's like, oh, vitamin B12 or whatever. So you go buy milk or steak or I don't know what the heck is. And then you're like, oh, now you need protein. Here, let me go. And you go buy an egg and you crack it and you cook up an egg and you go, there you go, have some protein, kid. And you could do that. That's conventional farming. We like look at our plants and it's like, okay, today they need more phosphorus, call in the order, have the plane come by and dump a bunch of phosphorus on it. The hippie way to raise a kid is to just have a pantry that's full of everything. And then you just give your kids a little of everything. And you don't have to worry that they might need B12 or vitamin C or protein because you just fed them 1,000 things yesterday. They're probably going to be fine today too. Two very different strategies to manage farming. And I'm sorry to do this to you, but this gets us into a few more details. We're not done yet. Now, the three big ones in farming are nitrogen, phosphorus, and potassium, NPK. You might remember I mentioned this a while ago that the phosphorus globally is running out. There's only so much in the rocks that we can reach. Now, we can add those. You can call in the crop duster to bring you a big spray of nitrogen or phosphorus or potassium or whatever. But the synthetic sources only last a little tiny bit. The plants will use them up, great. And then the gases will go to the atmosphere or the liquids will run off. So the funny thing about synthetic fertilizers is you pretty much got to do it every day. Maybe you've heard about people who like grow pot inside and they don't even have soil. They just have like weird plastic fibers and they just like pour bottles of juice on them all the time. Same idea. You just keep giving them nutrients every day. Now, this is expensive. It's difficult to control. It takes a lot of management. But, you know, if you've got sensors in the dirt, you like call the guy and say, yeah, we got to up the phosphorus tomorrow. And somebody else gives them a little bit more phosphorus. And you can do the Liebig approach. Find out what they need and add more of that. This is how we grow most of the world's food supply, by the way. Most of the stuff that you and I eat comes from this. I should mention that most of those fertilizers are synthesized from fossil fuels. Fertilizers are usually synthetic chemistry that's done in a factory somewhere. Somebody puts the stuff into bottles. Now, if you're adding organic material, right, you could put like 4 inches of dead animals on there. And then you just sort of step back and let the decomposers do their work. And every day they're going to free up some more nitrogen and some more phosphorus and some more potassium. So technically the crazy thing is that organic farming is cheaper in terms of fertilizer supply, right? Because you just like dump some stuff. Like there's details in your area, the stuff might be better a certain type. If you're growing one crop, it might want a different type of stuff. If your time frame is 2 months instead of 4, you might want blood meal instead of bone meal or whatever. But the crazy thing is that that's generally cheaper and it takes less work. You just kind of mix it into the dirt or pile it on top of the dirt and then you just kind of stand back and let the plants grow. It's usually safer. It's like less risky. But you know, the stuff that works on your farm is different from the stuff that works on my farm. So you can't scale this up. You can't have a big shot in Kansas City calling in the orders for 7 states. You can definitely do that for like conventional potatoes. There's like one guy that calls in the orders to run something like 2.5 million acres of potatoes being farmed across like 9 or 10 states, actually. Organic farming is like, I don't know, man. I know what works on my yard because I know my dirt and I know my amount of sunlight, but I don't know about that side of the fence. That's your dirt. So, when the economy started to scale up and we were trying to run more things more efficiently, organic farming kind of died out and conventional farming kind of thrived. Like, you can get a recipe of chemicals to grow potatoes, and then like you just call that in and have somebody deliver it, and then you're ready to deliver your chemicals. So maintaining a healthy soil ecosystem, that tends to be more complicated, but there is an interesting bonus. There's the three big ones, the macronutrients in fertilizer, but there's a bazillion micronutrients in fertilizer. These are used in rare amounts, a few atoms of this and a few atoms of that. Like if you look in a spice cabinet, right? Like my house will go through 48,000 gallons of milk before we use up one jar of paprika. But I'd like you to think of micronutrients as spices. They add unique little ingredients to the chemistry of an organism. Those little ingredients tend to make the organisms healthier and more complex. They have more flavor. So what's interesting is when you're just adding nitrogen, phosphorus, and potassium, you get these really basic, hollow plants. Like somebody who works out and has like a perfectly cut body, but they're kind of like dull and boring. That's conventional agriculture. Organic agriculture tends to be more complex. There's more little pieces in the mix. It's like that guy, has some interesting hobbies. Whoa, they play the violin. Holy crap, they speak Russian. And like there's all these interesting nuances. That's organic agriculture. Because decomposing life has so many little ingredients, it makes more little ingredients available to the soil, which makes more little micronutrients available to the plant, and you get more complex chemistry. So funny bonus, organic food really does taste better. And this is just not my opinion. It's like a blind taste test thing. Because, they grow in more complex soils because they have more complex inputs of nutrients. All right. By the way, I'm not like crazy proponent of organics or anything. That's just because I like to eat food. Okay. That's it for 8, 9, and 10.